Hi guys, and welcome to week 7. So this week is a somewhat unusual week in regards to the weeks that we've had in the weeks prior, and so this is the beginning of the midterm week. Don't get too nervous, because this is just the week in which you can begin to take it, and I'll give you the dates as early as this upcoming Thursday. Now, we do have a discussion board this week, initial posting due Wednesday, homework's due Sunday, and there's no quiz this week. So once again, the big ticket is posted, and that's due October 22nd, so hopefully you're working on that. The midterm exam date range, the window is between October 5th and October 12th. The review has been posted. It's very, very, very important that you read through that. I won't read through that for you here to save you that time and allow you to do that on your own. But it's very important that you read it for specifics about going to the testing center, what they require, what they allow, and what you're allowed to bring, and all that fun stuff. So October 5th is this upcoming Thursday. You're welcome. I encourage you to get it done early, or as early as possible. If you wait till the last minute, you're risking a lot, and this is the window, and the window closes on the 12th. So please read that. Let me know if you have any questions. This week's content is still on the midterm. So if because this module is technically posted and you have it available for the weekend of week 6, and some of you, I know you like to get ahead and move forward, then you can certainly complete the content sooner and be ready to take the midterm on October 5th. So this week you'll be looking at a discussion board related to compound interest on a fun little video clip, and you'll be looking at sums and differences of functions. So useful concept. I'll do the discussion board wrap up next on Buck's Sporting Goods. And so you were told that you had these 3 locations, Alpha County, Beta County, and Gamma County, and each one sort of had its own rate of change. So Alpha County was growing by had a population of 2.4 million people, 2.7, 2.05 respectively. Alpha County was decreasing by a constant amount each year, 100,000, but Beta County is expected to decrease in size by 4%. So we know that's an exponential function, and Gamma County is expected to increase by 2%. That's an exponential function. Remember, percentages are not based off of the initial population size, but whatever the current population size is. Therefore, if the population size changes, so does the amount by which that population size increases or decreases. So we want to know, after 4 years, if we're planning on breaking ground, which population will be the largest at that time? And then what about 6? Will the answer still be the same? So we start off by looking at Alpha County, and we know that initially there was a population size of 2.4 million. So we've got to get things in millions, or at least get things on the same level. So I don't really want to use 2,400,000. I would rather convert things to smaller numbers, and so 2.4 million, or 100,000, is really 0.1 million. And you can do that by figuring out what fraction of a million 100,000 is. Well, there are 10 100,000s in a million, therefore 100,000 represents 1/10, or 0.1 of a million. So 100,000 divided by a million is 0.1. So we reduce the population size by 0.1 million people per year times the number of years. Beta County is similar, starting value of 2.7 million, but there's a decrease of 4%. Well, 4% is 0.04, and if we look at the whole 100% of people, that means that each year will only retain 96% of the population size of the previous year. And so here's our function, and because we're repeatedly multiplying by 96%, that results in an exponent. If you multiply by something repeatedly, then it's really that number to power representing the number of times it's multiplied. Gamma County is similar, 2.05 starting population, but we're adding on to the 100%, so 2% is 0.02. Remember, percent means per 100, or divided by 100, so 2% is 2 per 100, and so what we basically can say is that each year we expect the population size to be 102% of what it was the previous year. So the next thing we want to do is we actually want to study this, so best way to look at it is graphically, because there's a lot going on here. So let's see. I have Desmos pulled up somewhere here. There it is. Okay, so there's the first function, and so that's my linear function, which is what I would expect. There's Beta County in blue, and here's Gamma County in green. So what I do see is that Gamma County does actually pick up in population size at some point. Now if I look at time 4, I'm zooming in on time 4 here, I can see that at time 4, Alpha County is actually, of course, as we'd expect, even though it started off as one of the highest, it is now the lowest population size after 4 years. And one thing I can do here is if I type in x equals 4, I can see what those points are, because x equals 4 is a vertical line. And so I can see what those populations are, and I can compare them at time 4. And clearly, Beta County is the highest, even though it has a decay rate. It is still the highest at time 4, 2.293 million people. But if I look at this at time 6 years, so one thing I can do in here is just change this because that little slider pops in there. I could just leave one at time 4. Let's just leave one at time 4 for comparison purposes, and then I'll do one at x equals 6. Okay, so at x equals 6, I again compare the values, but now I see that the function corresponding to the graph of the green curve is the highest, so that corresponds to Gamma County. So even though it had the lowest initial population of 2.05, at time 6, it had a population size that outgrew all of the others. So it takes a little while for that small population size at a low percentage growth rate to eventually pick up because of the fact that we're taking 2% of the previous year and adding it to the current year. So our answer changes depending on whether we're looking at year 4 or year 6. Very, very interesting kind of idea. And the more we zoom out, the more we can see that curvature. We can see these functions really start to pick up over time. And why does that happen? Well, because you're taking 2% of an increasingly larger population size. I should say 102% of an increasingly larger and larger population size. And therefore, that population will eventually take off. So when we say things in the real world, when we use that terminology, something is growing exponentially, we're just saying that there's sort of a compounding effect, that it's a percentage growth rate or a percentage decay rate. So that's it for this week. Be working hard, study for that midterm exam. Let me know if you have any questions, and finally, have a great week 7. Take care.